This is a sewage treatment plant. This sewage treatment plant is used to convert wastewater into treated water, and the treated water is used for tree plantation. This is the control panel of the STP. Now I was informed that the cooling fan in the panel was not working. This is the filter of the cooling fan. Now I will open the panel and see on the right top is the cooling fan, and it is not working. So we will now check how to troubleshoot this problem. As we use PLC in the panel, this cooling fan is mandatory to keep the temperature down. If the temperature rises, the PLC will not work properly. To keep the temperature down in the control panel, the cooling fan is very necessary. So for every electrical troubleshooting, we need the drawing. If there is drawing, the troubleshooting will become easy and very quick. Now we will open the fan drawing. Let's see where is the fan drawing, and we will open that exact page number. This is the fan drawing, and you can see the fan clearly. Now this is the fan. So the main line is of 3-phase and a neutral. You can see that 4 lines out of that 3 line is phase 1, 2, 3, and last one is neutral. So they are taking a single phase. The single phase comes to the MCB named as Q fan, which is 6 amps and single pole, and from MCB out the wire number is B22. So the output of the MCB wire number 22 goes to the input of the TH. Now what is TH? TH is thermostat, and again from the output of the thermostat wire number B23 goes to the input of the fan, which gives phase to the fan on one end, and the second end that directly goes to the neutral. So this is how the fan gets phase and neutral. Now we will compare this drawing to the panel, and let's see where the components are located inside the panel. Now here is the panel. Now we will open the panel. So here is the drawing. One line from the phase directly comes to the MCB named as Q fan, which is 6 amps and single pole. So let's check the MCB in the panel. Now see the naming on the panel, F1, F2, F3. Now we have to search for Q fan, and this is the Q fan here, Q fan MCB, single pole MCB. And now we will check the wire number of the output of the MCB. It should be B22, and see it is B22. Cross check the drawing, and the output of the MCB wire number is B22. So we are on the right path, and it goes to the TH. TH means thermostat. Now search for TH on the panel, and here you can see that TH on the right corner, TH. So the input of the TH should be B22, which comes from the output of the MCB. So you can see the wire number B22 comes to TH, and the output should be B23 as mentioned in the drawing. See, the output wire number is B23, and the other end of the fan is directly connected to the neutral. Now we require a multimeter, and I will turn the knob to the AC voltage. Now we will cling the multimeter to the panel so that it will be easy for us. Now keep one probe on the MCB incoming supply, another probe on the neutral, so that neutral we can take common. I will show you how. Now here is the Q fan MCB, which we have to keep on the incoming of the Q fan MCB, another probe on the neutral, which is common. Then check the voltage. It is 238 volt AC, so means it is receiving power supply on the incoming end of the MCB. Now outgoing end of the MCB, the breaker should be turned on. See, now it is good. Now we will keep the probe on the thermostat incoming wire, which is B22. Now it should get voltage if the circuit is good. Yeah, it is getting voltage. Now keep the probe on the outcoming of the thermostat. So here there is no voltage, so the thermostat is not becoming NC. For this, the thermostat should match the condition or the set value, then only this thermostat will become NC and it will get phase voltage and the fan will run. The set temperature on the thermostat is set to 26, but here now winter is going on, so the temperature is still 22. So it will become NC when thermostat matches the set temperature. Now we can check the thermostat is good or not by decreasing the temperature in the thermostat by rotating the knob. Now see, if we rotate or decrease the temperature in the thermostat, the fan should run. Now let's check. See, the fan is running. As we decrease the temperature on the thermostat, the fan is running, so the thermostat is good. In this troubleshooting, the electrical circuit is good. The only problem is that the thermostat didn't satisfy the set temperature, so here there is no issue in the electrical circuit. Now we will check the voltage from the thermostat out to the neutral. One probe on the neutral and one probe on the thermostat out. Check the voltage 240. So the circuit is good. This is how we troubleshoot with the drawing.